Very good morning everyone, distinguished guests, faculty members and your wives. It is my privilege to introduce our esteemed speaker, a scientist who exemplifies innovation at a national scale. Dr. Ashish Agarwal is the Chief Scientist and Head of Time and Frequency Metrology at CSIR National Physics Laboratory. What makes his work particularly relevant to design thinking is his approach to solve complex challenges, leading a 100 crore national network of laboratories across 5 cities and developing atomic clocks for India's navigation satellite system, NAVIC. With an MSc from IIT Kanpur, a PhD from JNU, and research experience spanning institutions in Japan, USA, TIFR Mumbai, and IIT Delhi, Dr. Agarwal brings a unique perspective on translating scientific principles into scalable, impact-driven solutions that serve critical national infrastructure. Please join me in welcoming Dr. Ashish Agarwal.
Thank you.
Sir, CSIR sir, I please request you to facilitate our guests.
Oh, thank you. Thank you.
Thanks for coming.
Thank you very much.
Thank you very much.
Thank you.
Stage is all yours, sir.
Thank you very much. Thank you. Nice.
Sir, the platform is all yours.
Thank you very much. Good morning, everyone. I am very happy to be here, and thank you for the invitation. And we look forward to this this lecture because it is something new which I have attempted, and I am not a management person, but even then I have tried to bring it to your language as such. I hope it is as per your requirement, but basically I have given a topic of design thinking because that is what we need to do every day, and that is what we were just talking about. And the problem which we are going to solve, a national problem which we are going to solve here is going to teach us that how a good planning, how a good design thinking will help solve bigger problems. You know, of course, problem can be very small or problem can be very big, but how to tackle that problem, how to define that problem, how to how to make a prototype of that, and how to test and validate. So these are the things which we like to learn. So I'll begin with the. Is it possible to have this thing, or okay? I'll do it from here. So probably yeah. So okay yeah. So the way I'll emphasize this topic. We'll bring to you a challenge which a user, in this case the user is the country, the nation. So the nation is a user, and it's trying to counter certain challenge which it has faced. So the challenge was the Kargil war. So my whole lecture will bring into you, if we face a challenge, if a nation, a user faces a challenge, how do we tackle that challenge? And why it is a technical challenge? Why something which a nation faces, what kind of technical challenges it face? I'll introduce something called GPS, which we have all heard. So how this is related to a technology, a very strategic technology of GPS. So we'll define a problem, a strategic problem, a design thinking problem, that what this issue of Kargil war will bring to us. So I'll try to further break in this problem into different parts, and one of the problem is to innovate, to create something called atomic clocks. So how one thing is leading to another, another thing is leading to the third thing, that is what I'm going to bring about. And then what kind of technology is required, and how do we create that technology to solve this problem, which is basically technology of constellation of satellites. It's a much bigger than what we thought about. Initially it's a very trivial problem, but then it became a very big problem that we have to have certain constellation of satellites for this solving this problem. So, and then finally, once we have certain things in technology which is already implemented, how do you really test and validate it? Whether it is really as per the requirement or as per the solution which we want to implement, whether it really solves the problem or not. So that is what my last point will be, test and validate the performance. So basically I've introduced you the outline. The empathy here is the Kargil war, as I already explained to you. So we are trying to do the user is the nation. The year was 1999 when we had this issue. And the problem was, the empathy was, the Pakistani troops disguised as Kashmiri militants covertly infiltrated into strategic positions in the Kargil's How mountain on the Indian side of the LOC. So this is the LOC, and they were trying to infiltrate in the Indian territory or oversee the How mountains, and we need to counter them. So they were all occupying the high positions in the country on the LOC. And how we were not prepared, the country, the user was not prepared. So there need to be AI implemented then. Had we had the AI at 1999, we would have done the risk simulation earlier. That time we were not prepared for this kind of risk simulation. So we were not prepared that this kind of intrusion will happen. And there was no AI at that moment of time, so there was no risk simulation as such. So had we implemented AI that moment of time, the generative AI, we would have known this kind of risk which we are having in the country or for the user. So I think with that introduction, why country faced this kind of challenge, the user faced this challenge. So in the Indian military sought GPS data of high altitude mountainous terrain to pinpoint Pakistani troops occupying Indian positions to be used by Indian fighter pilots. So what happens is when they are occupying these positions, the militants are occupying these high mountains, the Indian military, they need to know where to target, how to target, and they need to know what are their positions. And now you are very much aware that once you want to calculate your position, what do you use? What technology do you use? Absolutely. So that's what I want to do here from you. We use GPS. So this was 1999, and government and the military sought the GPS data of those high mountains so that they can target the military troops, which are Pakistani troops, which are occupying those positions. Now we need to understand the user's need, the strategic need for guaranteed autonomous access to the PNT data. What is PNT? PNT is position, navigation, and timing data. So if at all we need to counter this, we need to have their position, we need to navigate, and we need to know the timing of their locations. So this is called PNT, position, navigation, and timing. Can we remove this thing? Because something is getting cut. I cannot see the bottom thing. Is it possible to remove this? No, not really possible. Okay, oh, it's so fine. It's fine. So anyway, I am talking about if at all we had known that moment of time, 1999, the PNT data, the position, navigation, timing data, we could have done some AI on that. That how to, that time there was no generative AI that moment of time. So I am trying to bring a design thinking problem to you. That the design thinking problem is to have a PNT data of that area. How to generate a PNT data of that area. So that is the design thinking problem, and that is what we are trying to understand. So can we now use the generative AI to quickly learn about the GPS? What is GPS? Why is it really required in the Kargil war? And what was the meaning of GPS. So now because we are in the present era where we use the generative AI, so we learn about the GPS from the AI. What AI says about GPS is, the GPS is having 24 satellites. So this is Earth, and these are the satellites which are going around the Earth, and these are 24 in number. So there are 6 orbital planes on which these satellites are moving. 6 different orbital planes are there. Each orbital plane is having 4 satellites. So each circle is having 4 satellites. The orbital planes are actually having 55-degree inclination with each other, and the satellite position is about 20,000 kilometers above the Earth surface. And each satellite is having 12 hour in which it goes around the Earth, one full Earth circle around that, and the speed of a satellite is 3.87 kilometers in 1 second. In 1 second it goes about 4 kilometers. You can imagine the speed. So at least 4 satellites are always in view. That means at any position on the Earth, because Earth is spherical, and if you are at this position, how many satellites are really above you? How many satellites are visible to you? So that is what I have written here. At least 4 satellites are always in view to any position on the Earth. So that is why there are 24 satellites in total. Because you will not be able to see all 24 satellites right now, because some may be down there below the USA or somewhere, which is back of the Earth, back side of the Earth. So suppose you are here and satellites are here or above this thing, you will not be able to see them. So there are only 4 to 5 satellites which you can see at any moment of time. So then what is special about these satellites? Why do you need these satellites? And because it's called GPS, and the full form of GPS is Global Positioning System. Very good. You are good students. And so these are developed. So these are developed by U.S. Department of Defense. So it belongs to USA. First is most important thing I have written here is, it is a technology of U.S. Department of Defense. So it is meant for defending a country, defending the America. So this technology, in each of these satellites, there is something called atomic clocks. We'll slowly try to ask AI what is atomic clock also, because we need to progress now. We need to know what is atomic clock. And there are 2 kinds of atomic clocks which I have written. There is something called cesium atomic clock, and there is something called rubidium atomic clock. So this satellite is having atomic clock on board. And we are talking about war in 1999. The technology was developed by USA in 1978. The first satellite was launched in 1978. So, this technology is existing for more than 50 years, as we can see now. So it's not that something which very new, but certain things which we use today, they have been planned many years back. So that is also a design thinking problem. So like something which is being used today was really planned in 1978 or earlier than that. It was implemented in 1978. It might have been planned even decades earlier, actually. So now, as I said, GPS is Global Positioning System, and it is required to calculate the position, navigation, and timing, PNT. So how do we calculate location and timing using these satellites, using this GPS technology? So GPS positioning starts with fundamental principle of measuring time. How a GPS measures time? Each satellite transmits a signal detailing where it is. So when there is a satellite here and you are on this Earth at this location, and this is the satellite, so this satellite is transmitting the satellite position in its signal and also the send time. So it is detailing where it is, that is the satellite position, and exactly when the signal left the satellite's atomic clock. So as I said, there is an atomic clock on board, and that is sending the time when the satellite left the signal left the atomic clock. So we need to calculate the distance or the time taken from the satellite to the receiver on the Earth. Now this receiver, what is the receiver? The receiver is receiving the signal from the satellite. This receiver can be your mobile. Each of your mobile is having this kind of electronics, which is also having an antenna of the satellite. This satellite signal is reaching your mobile. This can also reach a fighter pilot. This is a fighter pilot, fighter plane, where there is a GPS antenna. So many technologies are there. I think there is something called antenna also here, but probably it's hidden besides that. But see, whatever it is, so now the satellite position is there, the send time is there in the signal, and your arrival time is calculated by your device, by your mobile device or by the GPS antenna of this fighter plane. So the receiver on the Earth records the arrival time and subtracts the send time. So it is already signal is having the send time, and so it will know the travel time. So travel time is approximately 63 milliseconds. This is a very approximate number because it will depend on the distance from the location of the satellite and also where you are located on the Earth. Since the speed of light is constant, we know that speed of the light is a constant of the nature, and that is 3 meters per second. Speed of light is something which is very fundamental, and that is a fixed number, 8 meters per second. So multiplying the travel time by the speed yields the distance. So once you want to calculate the distance between satellite and the position, you are able to multiply this difference in time with the speed of light, and you calculate the distance. So now you know the distance between this position and this position. And similarly from second satellite, this position and this position, and third satellite, this position and this position, fourth satellite, this position, this position. So the fourth unknown, because we need to calculate the XYZ very accurately. So here I have written XYZ. So XYZ is basically the position of the receiver, your position. Suppose you are the user of this GPS. So you need to know your position, which is basically in mathematical terms, it is X, Y, and Z coordinates. So, so these coordinates are needed to be calculated. So normally this mobile or the receiver in the fighter plane is having a quartz clock. Like we have this quartz clock. I'll tell you also about quartz clock in detail in few slides. So these quartz clocks are also not synchronized with a highly accurate atomic clock, so they need to also calculate the time. So there is fourth unknown, which is time. So there are four unknowns, X, Y, Z, and time. And that is why we need to solve four equations to calculate three position coordinates and the receiver clock's error. So the satellite must track four satellites. That is why they have the requirement of four satellites to calculate four unknowns, X, Y, Z, and T. If you have to calculate four unknowns, that's a very, I think we are taught in the maths class in the school also, that how to solve four equations to calculate four variables. Four variables here are X, Y, Z, and T. So we are calculating four equations and try calculating the X, Y, Z. So now these four independent equations allowing the receiver to calculate its precise position and simultaneously calculate its old internal time syncing into the global GPS standard. So that is how this GPS works to let you know your position and time. So these are the 4 satellites which are there above you on the Earth, and you're trying to use these satellites to get the position on the Earth, and you get a signal from the satellite, and then you are able to calculate. This is called the arc, because the satellite like goes in a circle, like what I showed you here. So these are the 4 circles, because if satellite is here, then signal transmits all around it. So it's like makes a sphere, and this sphere intersects the Earth at certain place. So these are the 4 circles which we are making from a satellite. So the signal from the satellite is coming out and it is intersecting here. And that is what I show here. So these are different arcs, and wherever all the satellite signals meet, that is your XYZ. And that is where we now need to know the power of time, because time is the one which is used to calculate the distance between the satellite and the position of yours. Now, these satellites have atomic clocks, as I said. So now, if these satellites have atomic clocks, and this clock, they are not synchronized. Synchronized means they don't have the same time. Suppose they don't have the same time, and the error between these 2 clocks is only 100 nanoseconds. That means this clock and this clock is off by less than 1 second. A billionth of a second is nanosecond. So we are talking about 100 nanoseconds. Suppose this difference between this clock and this clock is 100 nanoseconds. The position error will be about 30 meters. Okay? So that is a very intriguing number. See, when we use GPS in our mobile, when we come to this institute, you might have opened your GPS and you want to know your position within a meter. Normally, if you are in this institution, you don't want to, being shown that you are at the metro station, or you don't want to be shown that you are in Connaught Place. So you want to be as close as possible, and that is why the accuracy comes into play. Now I am saying that if it is 30 nanosecond error between the satellite clocks, the position error is about 30 meters. So that means if at all we want to calculate the position of within few meters, the satellite clocks need to be synchronized within few nanoseconds. I mean, what is the meaning of nanoseconds? That is what also I will try to tell you. So why is the accuracy really important? Because as I said, satellite signal only takes 63 milliseconds from satellite to your mobile or to a fighter plane. It takes only 63 milliseconds to reach the receiver on the ground. And the synchronization error of 1 millisecond. Now, instead of 100 nanoseconds, I have given this number as 1 millisecond. So that will give a position of about 300 kilometers. So it's a bigger number. 1 millisecond is also 1,000th of a second. It's a very small number. Between this clock and this clock, if it is a difference of 1 millisecond, you are sitting here and you will be showing you are sitting in Lucknow. Actually, you are in Delhi, and it will show you are in Lucknow. So that kind of error you will get if at all this satellite clock is off by 1 millisecond. So we need timing accuracy of the order of few nanoseconds to get the navigation at the meter level, and that is why we need precise clocks synchronized to nanoseconds. So let us do this calculation once again, because I want to put it in your mind. I mean, this number, this talk is all about precision. We are talking about mind-boggling numbers, because we are using these technologies and we take them for granted. हम बहुत सारी चीज़ें ऐसे यूज़ करते हैं जो कि हम ये तो है ही हमारे पास, मोबाइल से हमें टाइमिंग पोजीशन तो मिल ही रहा है, कैसे मिल रहा है, somebody says GPS से मिल रहा है. अब GPS कैसे काम करता है, what is behind GPS, we don't know. And that is what whenever you are doing a design thinking course, lot of knowledge need to be known before we design, because you need to be at that expert level to do that design thinking problem. You should be able to cater to that problem once you know certain basics about it. So I said here, now I want only to be calculated within 1 meter. I want to know my position within 1 meter. I don't want to 300 kilometers or 30 meters. I don't want that. I want within 1 meter. And we know light travels by this speed, 8 meters per second. So 1 meter positional uncertainty, if you put it here, this number, this will immediately tell you 3.3 nanoseconds. So that is where you get very easy can calculate from this number. You can get 3.3 nanoseconds timing uncertainty. So GPS clock to be stable within 3.3 nanoseconds. So that means whenever these two satellites are there, the clocks on that, they need to be within 3.3 nanoseconds. But how long? So every 12 hours you can correct that clock also on the satellite. But they need to be at least for within 12 hours. They should only drift by 3.3 nanoseconds or less than that. That means the uncertainty of drift also need to be very small. अगर आप ये देखेंगे कि आपकी जो घड़ी रिस्ट वॉच है, आप कितने दिनों में उसको एडजस्ट करते हैं. हम कह रहे हैं कि जो घड़ी सैटेलाइट के ऊपर है, ये 12 घंटे में नैनो सेकंड में चेंज होना चाहिए उसको. आप अपनी घड़ी को, क्वार्ट्स वॉच को कितनी बार चेंज करते हो, सिंक्रोनाइज करते हो किसी रेफरेंस से, जैसे टीवी के टाइम देख के या मोबाइल का टाइम देख के. आपके घर में कोई घड़ी लगी है दीवार पे, वो स्लो या फास्ट हो जाती है, इट गोज स्लो और फास्ट. सो हाउ ऑफन डू यू नीड टू चेंज द टाइम ऑफ दैट. मे बी 1 साल में एक बार या 6 महीने में एक बार 4-5 मिनट दिखने लगता है कि 5 मिनट घड़ी मेरी स्लो हो गई है, फास्ट हो गई है, तो मैं उसको जाके चेंज कर देता हूँ, उसको जाके सिंक्रोनाइज कर देता हूँ. सो दैट मीन्स दैट वॉच इज ड्रिफ्टिंग बाई मेनी मिनट्स in many months. So, but here we are talking about nanoseconds in 12 hours or 1 day. So it is a very small drift which we are talking about. So these are very, very stable clocks. So GPS clock to be stable within 3.3 nanoseconds, 12 hours, and clock is corrected from Earth every 12 hours because that satellite clock is corrected from Earth, because if it is drifting, will not be good clock. And this is basically talking about the stability of the clock, how stable it should be. Stability of the clock is calculated by the drift and the time. So this is the delta t, the drift in clock, which I said is 3.3 nanosecond. So I write 3.3 nanosecond is 3.3 into 10 minus 9 seconds. That is 3.3 nanoseconds. And 12 hours is how many seconds? 12 into 60 into 60, that is 43200. So you divide delta t by t and you get this stability. So you need to have a clock which is stable of the order of -13. -13 stability is very, very small number. So we don't want your clock to drift. And that is why GPS requires a very highly accurate and stable clock. Let us understand what is a clock. घड़ी क्या होती है. हम यूज़ तो करते हैं, लेकिन कैसे घड़ी आई, कहाँ से घड़ी आई, क्यों घड़ी आई, उसका क्या यूज़ है, कैसे उसको इवॉल्व करा गया. सो नाउ एआई की प्रॉब्लम हम दी एआई को, भाई हमें घड़ी के बारे में बताओ, घड़ी कैसे काम करती है, क्योंकि अब हमें नैनो सेकेंड्स मेजर करनी है. नैनो सेकेंड्स को कैसे मेजर करेंगे घड़ी में. तो हमारे पास बहुत सारे तरीके हैं टाइम मेजर करने के. सन से हम मेजर करते हैं, जिसके बारे में बताऊंगा अभी मैं. सन का रोटेशन जो है अर्थ के चारों तरफ मेजर करते हैं हम लोग. अर्थ की एक्सिस पे जो सन घूमता है, वो अर्थ घूमती है, उसके बारे में बात करेंगे. वाटर से भी हम, वाटर के फ्लो से भी हम टाइम को मेजर कर सकते हैं. ये कैंडल है जिसमें इसमें एक हमने कील लगा रखी है, आयरन नेल, एंड दिस इज ऑल्सो ऑफ आयरन. सो एज सुन एज द वैक्स मेल्ट्स, this nail will drop and make a sound. So it's like a candle clock. So it is like it's like a stopwatch or a alarm clock. So it's one way to measure time. But then we know obviously pendulum is also one thing. So the other thing is quartz. I'll talk about quartz also, what is inside our wristwatch. So this is our wristwatch. What is inside the wristwatch also? This kind of oscillation of the crystal is there inside this wristwatch, and this is called quartz. And then we also used to have a shadow clock like Jantar Mantar, which we have. The one which is in Delhi or Jaipur or Ujjain or wherever. So all these places have these kind of shadow clocks, and I'll talk about that also. What are these kind of clocks? So we ask regenerative AI, what is a sundial? What is a Jantar Mantar? How does Jantar Mantar works? How this clock works? So what AI told us, that this is basically used to measure the height of the sun in the sky to indicate the time by the length of the shadow it produced. So in the morning, the sun is here, it's starting rising, and the shadow is made at the position A, and as the sun rises and goes to the zenith on the top of the head at the position B, the shadow becomes the smallest in the day. So this is very small shadow compared to the length at the morning or in the evening, and that is where we measure the time by the length of the shadow it produced. So at 12 noon, the shadow will be smallest in length, and that is when we will know it is 12 noon. So always, without any watch, you can know that it is 12 noon by looking at the length of the shadow. And that is what the Jantar Mantar also does. Now this genome, we call it, this line need to be parallel to the Earth's axis. So that whenever you, अगर जंतर मंदिर को दिल्ली में देखोगे और इंदौर में देखोगे या उज्जैन में देखोगे या फिर जयपुर में देखोगे, you will find this angle to be different. This line should be parallel to the Earth axis. So that is the way these sundials work. Bar parallel to the Earth's axis will cast a shadow in the same direction at the same time every day of the year. So that is how the genome, I think in schools also nowadays in the space modules which they have, they teach us about the sundial and how these genomes work and how they are used to calculate time, how these clocks work. These are very primitive methods of measuring time, but we need to understand these primitive methods also to measure time. Oh, sorry. This is also very well known. This was discovered in 1582, the pendulum clock, and this was having an error of 1 second because each oscillation घर में जो होता है वो भी 1 second से measure कर सकते हैं. अभी हमने एक और चीज़ के बारे में बात करनी थी मुझे. See, when the human civilization evolved, there were kingdoms across the world, and there was a very famous kingdom called British Empire. The British Empire has a desire to capture the whole world. They wanted to rule the whole world, and that is why they came to India also. So in 18th century, when the Britishers want to come across the world, they had to use ships. That time there was no aeroplanes and there was no space flights and all that. So only way to transportation was the ships. So they used to calculate their position using the east-west position. So you need to know your longitude and latitude. So now when you're on a high sea, a ship is on the high sea, how does it know its position and how does it navigate? How does it find its way? Because on sea, everywhere there is water and you cannot, you don't have any way to know where you are. There are no landmarks. Like on the road, you have landmarks and you know that where you are going and all that. But in the sea, there are no landmarks. So the accurate navigation led to significant economic and military losses. अगर वो navigation नहीं कर पा रहे थे ना ships को, तो उन्हें उनका ship या तो आइसबर्ग में क्रैश हो जाता था, या फिर उन्हें मालूम नहीं चलता था वो जाना चाहते थे यूएसए पहुंच गए इंडिया, तो always there used to be some problem or the other. So there were a lot of economic and significant losses and they were not able to track their way, navigate नहीं कर पा रहे थे. The only situation required the accurate knowledge of time over long voyages. तो तब उनको टाइम की जरूरत पड़ी, एक्यूरेट नॉलेज ऑफ टाइम की जरूरत पड़ी, उससे पहले जरूरत नहीं थी. या कम इन नो नॉट एट अबाउट. सो उस समय क्वीन ने कहा, ब्रिटिश क्वीन ने कहा कि यू नो whoever can make a very accurate clock, I will reward him. Why was really clock required? पहली बात तो ये समझना है कि नेविगेशन के लिए क्लॉक की जरूरत क्यों पड़ती है. तो एक तो हमें लैटिट्यूड निकालना होता है शिप का, और एक लॉन्गिट्यूड निकालना होता है. लैटिट्यूड का मतलब नॉर्थ साउथ का डायरेक्शन, आप कितना इक्वेटर से दूर हो या इक्वेटर के पास हो, इक्वेटर के ऊपर हो या इक्वेटर के नीचे हो, तो आपको अपना लैटिट्यूड निकालना है. लैटिट्यूड निकालने के लिए शिप को क्या होता है कि सन की पोजीशन देख ली, सबसे ऊपर सब जब पहुंचा जेनिथ में, तो उस समय अगर आपने देख लिया सन कहाँ पे है, तो आपको उसका लोकल टाइम पता चल गया. लेकिन लैटिट्यूड निकालने के लिए आपको सन कितना ऊपर है जेनिथ से, या फिर हॉराइजन से कितना ऊपर है, या पोल स्टार अगर आप देख लो तो पोल स्टार का कितना पोजीशन, क्या पोजीशन पे है पोल स्टार, उससे आपको अपना लैटिट्यूड पता चल जाता था. तो शिप्स के पास वो एक बड़ी बड़ी टेलीस्कोप्स भी होती थी, और उससे वो स्टार की पोजीशन देख के अपना लैटिट्यूड निकाल लेते थे. सो उससे उन्हें एंगल ऑफ द सन से या स्पेसिफिक स्टार से दे कैन फाइंड आउट देयर लैटिट्यूड वेरी इजीली. लेकिन लॉन्गिट्यूड निकालना असंभव था. लॉन्गिट्यूड नहीं निकाल सकते थे वो किसी भी तरह से. दिस वॉज वेरी वेरी हार्ड. लॉन्गिट्यूड इज डिटरमाइंड बाय द टाइम डिफरेंस बिटवीन शिप्स लोकल टाइम व्हेन द सन इज हाईएस्ट एंड द टाइम एट ए फिक्स्ड रेफरेंस पॉइंट से लंदन. अगर शिप चलाए लंदन से, तो लंदन की घड़ी तो है उसके पास, तो उसे लंदन की घड़ी लेके चल दिया वो, और वो अभी पहुंच गया सपोज इंडिया के पास. तो फिर वो देखेगा कि इंडिया के ऊपर जब वो है शिप में पानी में, तो सन जो है होराइजन पे किस समय पहुंचा. मान लो उसने देखा कि लंदन की घड़ी में दिखा रहा है रात के 12 बजे सपोज, और जब यहाँ पहुंचा तो उसका उस समय टाइम दिखा रहा है 5:30. तो बेसिकली मतलब ये है कि जो सन का पोजीशन है उससे आप 12 बजे निकाल सकते हो. तो अब आपको डिफरेंस पता चल जाएगा कि मेरा लंदन में तो इस समय टाइम ये हुआ है और यहाँ पे 12 बजे दिखा रहा है, तो मतलब लंदन में 5.5 घंटे कम होंगे, तो मेरी घड़ी में कम टाइम दिखाएगा, यहाँ पे ज़्यादा टाइम दिखा रहा है. सो फ्रॉम दैट यू आर एबल टू कैलकुलेट द लॉन्गिट्यूड. एंड बिकॉज हर 15 डिग्री पे 1 घंटा चेंज होता है अर्थ पे. अर्थ का रोटेशन में अगर आपको याद होगा कि अर्थ जो 24 आवर्स में रोटेट करती है, तो हमारे 360 डिग्रीज का पूरा लॉन्गिट्यूड्स है, 360 लॉन्गिट्यूड्स हैं. तो अगर आपको 1 घंटे का डिफरेंस किसी जगह पे है, 2 टाइम जोन अलग अलग हैं, तो उसके बीच में 15 डिग्री का डिफरेंस होगा. So I hope I have a way to is it this works? I hope it works.
That's on the board.
Oh, that one?
No, for the smart board itself.
स्मार्ट, अच्छा यहाँ पे
हम उसको switch करें.
नहीं, अगर छोड़ो अगर प्रॉब्लम होती है तो छोड़.
नहीं, इसको 1 मिनट में switch करें.
हाँ, अच्छा, ओके.
Now it should work.
Yeah, so what we are trying to find out the latitude and longitude. So, oh, I'm sorry.
10.
Oh, okay.
There you go.
Okay. So I am trying to. So now we know that this is the prime meridian, and when we have a map, this is the prime meridian. The London is here. And suppose, we have these lines. So this is 0 degree, and every 15 degree there is 1 hour difference. So इंडिया और लंदन के बीच में 5.5 hours का डिफरेंस है. दैट मीन्स देयर इज द डिफरेंस ऑफ 75 degrees. So suppose India is here So this will have a 5.5 hours difference, 5.5 hours difference, and this is actually 75 degrees. So every 15 degree is 1 hour. That is what we know. So I think I'll go back.
So you will have to click on the circle and then
Click where?
there's the wheel at the center. Wheel at the
Oh.
center of the screen.
Oh, okay.
Click there. You go to.
Okay, thank you. Thank you for helping me. This technology, I am not a... Thank you. Yeah. Thank you. I'll probably not use it. So, so what we are trying to find is longitude now using the clock. So the ships were able to tell us the longitude using the time difference with the local clock and the clock which they were carrying from London or from the UK. So from that they were able to calculate the longitude, and that is the way to navigate. But now if the clock is having very big uncertainty, जो clock लेके चल रहे हैं वो उसके बीच में uncertainty बहुत ज़्यादा होती है, तो उनको क्लॉक का टाइम जो है, क्योंकि शिप जो है रॉक एंड रोल करता है वेव्स में और पानी में, सो इट इज़ नॉट सो गुड. सो दैट इज़ वाई द क्वीन सेड जो बहुत अच्छी घड़ी बनाएगा उसको हम अवार्ड देंगे. तो उसको 5-10 साल लगे. एक कारपेंटर था जिसका नाम था हैरिसन. सो जॉन हैरिसन वॉज एबल टू इन्वेंट ए क्रोनोमीटर इन 1761, एंड दैट वॉज बेसिकली ए पोर्टेबल टाइम स्टैंडर्ड, and that was basically counter oscillating beams and springs. So motion was not influenced by the gravity or the rolling of a ship. So it was a very accurate clock. How accurate was it? It was able to calculate the time by the 1/5 of a second a day. So very, very accurate clock. So that moment of time you are able to make a clock which is accurate to 1/5 of a second a day. So this was a very good clock, and Queen was able to reward him. There was a lot of questions being asked, but now that this technology was not there at that moment of time. 1700 में ये क्वार्ट्स नहीं था उस समय, ये बाद में आया है. तो ये 19th सेंचुरी में आया है क्वार्ट्स. व्हाट इज क्वार्ट्स? जो हमारे आजकल हम लोग कॉमनली यूज कर रहे हैं. क्वार्ट्स में इज बेसिकली मिट्टी. क्वार्ट्स इज अ क्रिस्टल ऑफ सिलिकॉन डाइऑक्साइड. सो इट इज हैविंग 2 atoms of oxygen and 1 atom of silicon. So it's having very fixed structure. So this is silicon and this is 2 atoms of oxygen, and this is like a crystal. So it's having very defined lattice, and it is abundant in nature because it is amorphous form is called sand, मिट्टी. जो नॉर्मल मिट्टी होती है वो सिलिकॉन डाइऑक्साइड ही है. And that is so prevalent, omnipresent. Only thing is we have to make a crystal out of it. So once we make a crystal out of it, and you apply current, it will start oscillating. How it will start oscillating also I will tell you next slide. But basically I am trying to use this crystal to measure time. How do I use it? So these crystals, as I said, they are having silicon and oxygen atoms. So the charges of these crystals are cancelling each other when there is no current on this crystal. So as soon as we apply a certain current on this crystal, the crystal will deform. Switch is closed, current flows and the crystal deforms. The crystal gets shorter and fatter. And if you reverse the polarity of the current, the crystal will become longer and skinnier. So basically I am trying to only tell about this kilomagnetic effect. I don't want to bore you with this physics, but I am only trying to tell you that if you apply a current on this crystal, it will oscillate. The things will oscillate, and that is called electromagnetic effect, and this was discovered by Madison and Horton in 1927. So this is when the crystal clock was made, and that is called quartz clock. So it is this kind of crystalline dioxide, silicon dioxide, and when you apply force on it, it will have polarity, and it affects a piezoelectric effect. So क्वार्ट्ज का सबसे अच्छी खूबी ये है कि बहुत स्मॉल साइज का क्रिस्टल होता है. ये हमारी घड़ी के अंदर इतना छोटा क्रिस्टल है कि हम उसको पता भी नहीं है हमें कौन सा कहाँ पे क्रिस्टल लगा है. बड़ा स्मॉल साइज का होता है, इट इज हैविंग वेरी लो पावर रिक्वायरमेंट, वेरी लो कॉस्ट मिट्टी है वो, तो इट इज हैविंग ए वेरी वेरी लो कॉस्ट, वेरी हाईली स्टेबल, एंड इसका ऑसिलेशन फ्रीक्वेंसी 32768 हर्ट्ज. आई विल टेल यू व्हाई व्हाट इट इज. So inside our quartz watch there is a small quartz crystal, it's called quartz oscillator, and this is when once it is applied a current from the battery, it starts oscillating at 32768 hertz frequency, and in our analog watch there is a strapping motor also. So there is a small motor that receives one impulse from this crystal, and this will advance the second needle by 6 degree, and that is how the hour second needle moves in our quartz clock. So basically what is the meaning of 32768 hertz? What is the, ये क्रिस्टल जो है, जो क्वार्ट्स का है हमारी घड़ी के अंदर, ये ऐसे ऐसे ऑसिलेट कर रहा है, और ये ऑसिलेशन फ्रीक्वेंसी है 32 किलो हर्ट्स, 32768 हर्ट्स. अगर इस नंबर को हम 2 से डिवाइड करते हैं, यू डिवाइड दिस नंबर बाई 2 15 टाइम्स, you will end up with 1 hertz. So you keep on dividing by 2 15 times and you end up with 1 hertz. So in your watch, by getting this frequency 32768 hertz, you are able to divide it to 1 hertz, and that is where 1 hertz is fed as 1 second to your needle. तो आपको 32768 हर्ट्ज आपकी घड़ी के अंदर 15 बार डिवाइड होने के बाद 1 हर्ट्ज बन जाता है, और उससे आपको 1 सेकंड का टाइम मिल जाता है. सो आपका 1 सेकंड एक्यूरेटली कहां से मिलता है? क्वार्ट्ज क्रिस्टल से, बिकॉज यू नीड टू नो हाउ लॉन्ग इज 1 सेकंड. फाइनली वी आर ट्राइंग टू फाइंड आउट हाउ लॉन्ग इज 1 सेकंड. व्हेन कैन 1 सेकंड इज नीड टू बी डिफाइंड, नीड टू बी टोल्ड, नीड टू बी कैलकुलेटेड. वी टेक इट फॉर ग्रांटेड. 1 सेकंड का मतलब दिमाग में तो आइडिया है कि एक पल 1 सेकंड निकल गया, लेकिन 1 सेकंड कितना लंबा है, 1 मिनट कितना लंबा है, एक घंटा कितना लंबा है, ये घड़ी बताती है हमारी. तो 1 सेकंड से हमें पता चलता है 1 घंटा कितना लंबा है और 1 मिनट कितना लंबा है. अगर 1 सेकंड नहीं मालूम होगा तो हम घंटे के बारे में मालूम नहीं चलेगा, दिन के बारे में मालूम नहीं चलेगा. सो वी आर ट्राइंग टू फाइंड आउट हाउ लॉन्ग इज 1 सेकंड, and crystal is able to tell us how long is 1 second. लेकिन अगर आपने अपनी घड़ी को किसी पहाड़ पे ले गए या किसी गर्म जगह पे, रेगिस्तान में ले गए, बहुत गर्म जगह ले गए, तो उसका टेम्परेचर चेंज होने से उसकी घड़ी की परफॉर्मेंस चेंज हो जाती है, या तो वो स्लो हो जाएगी या फास्ट हो जाएगी. तो आपको ये पता चला कि घड़ी जो है आपकी, उसमें एक क्वार्ट्ज क्रिस्टल होता है, उसकी फ्रीक्वेंसी चेंज हो जाती है. अगर वो फ्रीक्वेंसी चेंज हो जाएगी, क्योंकि टेम्परेचर डिपेंडेंस है उसकी, द क्वार्ट्ज फ्रीक्वेंसी वेरीज विद टेम्परेचर. तो क्वार्ट्ज जो है टेम्परेचर के संग चेंज होता है अपने संग. सो लेकिन अभी हम क्लॉक्स घड़ी पे रह रहे हैं, तो हमने देखा घड़ी भी जो है ना, ये क्वार्ट्ज भी एक्यूरेट नहीं है. हमें एआई ने बताया कि क्वार्ट्ज इज नॉट सो एक्यूरेट एंड इट कैन चेंज एज द टेम्परेचर चेंजेस. हमारे घर में घड़ी भी थोड़े दिन में गलत टाइमिंग दिखाने लगती है. सो वी कैन नॉट रिलाई ऑन क्वार्ट्ज फॉर टाइम कीपिंग. तो सबसे एक्यूरेट चीज है एटम्स. तो एटम्स को हम यूज करेंगे फॉर टाइम कीपिंग नाउ, एंड दैट इज वेयर वी विल मेक एटॉमिक क्लॉक्स. सो नाउ in the new era we have atomic age of time standards. The atoms act as oscillators now. Instead of quartz we have atoms. अभी तक क्वार्ट्ज ऑसिलेशन के बारे में बात करी थी. तो एटम्स कैसे काम करते हैं? एटम्स के अंदर इलेक्ट्रॉन्स होते हैं और न्यूक्लियस होता है. न्यूक्लियस के अंदर प्रोटॉन्स और न्यूट्रॉन्स होते हैं, लेकिन हम न्यूक्लियस और इलेक्ट्रॉन्स की बात करेंगे. तो सेंटर में एक न्यूक्लियस है और चारों तरफ इलेक्ट्रॉन्स हैं जो नेगेटिवली चार्ज्ड हैं. सो वी आर ट्राइंग टू फाइंड आउट about the electrons and interaction between the electrons and the nucleus. लेकिन हमें यह भी बताया गया कि इलेक्ट्रॉन्स की डिस्क्रीट एनर्जी लेवल्स होते हैं. इलेक्ट्रॉन्स हैव डेफिनेट लेवल्स, they are not continuous. And if there is a light put on the atom, it will go from one state to another state. That means it will absorb that light and change its state, energy state. तो इलेक्ट्रॉन्स जो हैं एक एनर्जी से दूसरे एनर्जी जाते हैं और इसको कहते हैं एनर्जी चेंज. इट एब्जॉर्ब्स लाइट एंड चेंजेस इट्स स्टेट. एटम एक्साइट हो जाता है. एटम को आपने ग्राउंड स्टेट पे रखा है और उसके ऊपर लाइट डाली और एटम एक्साइट होकर दूसरी स्टेट में पहुंच गया, एनर्जी स्टेट में. And this lower energy state is called E1 and upper one is called E2. So the difference between this is fixed number. E is equal to h nu and nu is the frequency of the photon. ये आइंस्टीन ने बताया था हमें कि energy can be measured in terms of frequency. E is equal to h nu. H is a Planck constant and nu is the frequency of the light which you are putting in. जो लाइट हम एक्साइट करने के लिए एटम के ऊपर डालते हैं उसको हम किसी फ्रीक्वेंसी से मेजर करते हैं और वो फ्रीक्वेंसी अगर हमें मालूम होगी, अगर वो फ्रीक्वेंसी कम है तो उस लाइट का फोटोन की एनर्जी कम होगी, अगर वो फ्रीक्वेंसी ज़्यादा है तो एनर्जी ज़्यादा होगी. सो द फोटोन ऑफ लाइट विल हैव दिस काइंड ऑफ फ्रीक्वेंसी एंड दिस काइंड ऑफ एनर्जी एंड दैट इज वेयर वी यूज दिस फिनोमेना टू मेक ऑसिलेशन. तो दो एनर्जी स्टेट्स हैं, नीचे वाली और ऊपर वाली, और इलेक्ट्रॉन जंप्स फ्रॉम वन एनर्जी टू अनदर एनर्जी एंड इट एब्जॉर्ब्स ए फोटोन. So precise amount of energy is needed for electron to undergo a quantum jump and this is called quantum jump. What is the difference in quantum and continuous? Quantum is discrete. That means I cannot have energy level between something between. बीच में नहीं हो सकता. या तो यहां पे होगा इलेक्ट्रॉन या यहां पे होगा, बीच में नहीं हो सकता इलेक्ट्रॉन. तो इलेक्ट्रॉन ऊपर होगा या नीचे होगा. तो प्रिसाइज अमाउंट ऑफ एनर्जी इज नीडेड बाय मेजरिंग द फ्रीक्वेंसी ऑफ दिस लाइट विच इज गोइंग फ्रॉम टेकिंग द इलेक्ट्रॉन फ्रॉम हियर टू हियर. वी आर एबल टू क्रिएट द क्वांटम जंप. सो जो इसकी फ्रीक्वेंसी होगी वो डिफाइन करेगी, एटम डिसाइड कर रहा है वो फ्रीक्वेंसी. तो एटम ने बताया इसकी फ्रीक्वेंसी जो है 9192631770 हर्ट्ज है. ये कैसे पता चला? मान लो एक इलेक्ट्रॉन है जो ये न्यूक्लियस है एटम का और ये इलेक्ट्रॉन है और ये इसके चारों तरफ जा रहा है इलेक्ट्रॉन. अब ये इलेक्ट्रॉन अपनी धुरी पे स्पिन भी करता है, लट्टू की तरह स्पिन करता है, ऐसे ऐसे स्पिन करता है. ऐसे ही न्यूक्लियस भी स्पिन करता है अपनी दूरी पे. सो न्यूक्लियस इज स्पिनिंग ऑन इट्स एक्सिस एंड द इलेक्ट्रॉन इज आल्सो स्पिनिंग ऑन इट्स एक्सिस. सपोज दिस स्पिन इज पैरेलल टू द न्यूक्लियर स्पिन, दिस इलेक्ट्रॉन स्पिन पैरेलल, दैट इज वन एनर्जी स्टेट. इफ इट इज एंटी पैरेलल दैट इज अनदर एनर्जी स्टेट. सो अगर इलेक्ट्रॉन को ऐसे से ऐसे जाना है तो इसको एब्जॉर्ब करनी पड़ेगी एनर्जी, तभी वो ऐसे जाएगा. और कितनी एनर्जी, यहां से यहां जाने के लिए कुछ एनर्जी चाहिए लेकिन वो फिक्स्ड एनर्जी है, उसके ऊपर कुछ भी एनर्जी डालोगे तो वो ऐसे से ऐसे नहीं होगा. तो वो कितनी एनर्जी चाहिए? इस केस में, सीजियम के केस में 9192631770 हर्ट्ज की एनर्जी चाहिए हमें. अगर इतनी एनर्जी डालोगे इलेक्ट्रॉन के ऊपर तब वो फ्लिप हो जाएगा, अगर कम डालोगे तो फ्लिप नहीं होगा, ज्यादा डालोगे तब भी फ्लिप नहीं होगा. इलेक्ट्रॉन जब भी फ्लिप होगा जब एग्जैक्टली इतनी एनर्जी होगी, दैट इज कॉल्ड रेजोनेंस. So atom and light need to resonate with each other and that is where we need to have the power of atomic transition. एटम के अंदर ट्रांजिशन कर रहे हैं हम, एटम को यूज कर रहे हैं उस फ्रीक्वेंसी को मापने के लिए, मेजर करने के लिए. वो फ्रीक्वेंसी अगर 9192631770 हर्ट्ज होगी तभी एटम जो है एब्जॉर्ब होके एक्साइटेड स्टेट में जाएगा, नहीं तो जाएगा नहीं. तो ये मैंने यहाँ पे न्यूक्लियस दिखाया है, ये इलेक्ट्रॉन दिखाया है, इन दोनों का स्पिन दिखाया है. अगर ये न्यूक्लियर स्पिन और इलेक्ट्रॉन स्पिन पैरेलल है तो ये एनर्जी है. अगर न्यूक्लियर स्पिन और इलेक्ट्रॉन स्पिन एंटी पैरेलल हैं तो ये लोअर एनर्जी है. दोनों के बीच में एनर्जी डिफरेंस है जो इस फ्रीक्वेंसी से पता चलता है एंड दैट फ्रीक्वेंसी इज वेरी फिक्स्ड फ्रीक्वेंसी. सो दिस इज लाइक ए इनवेरिएंट ऑफ नेचर, इट डज नॉट चेंज विद टाइम. अगर एनर्जी जो है इतनी चाहिए तो चाहिए ही चाहिए, एटम को एटम की स्टेट चेंज करने के लिए इतनी एनर्जी चाहिए, और अगर इससे ज़्यादा होगी तब भी फायदा नहीं है, इससे कम होगी तब भी फायदा नहीं है. सिर्फ इतनी एनर्जी चाहिए तभी वो रेजोनेट होगा। तो इसी से क्वांटम ट्रांजिशन होता है और इसी से हम एटॉमिक क्लॉक को बनाते हैं। पहले हमने एटम को एक एनर्जी स्टेट में रख दिया, उसके ऊपर माइक्रोवेव डाले, मतलब 9192631770 लाइट डाली, और फिर अगर चेंज हुई तो ठीक एनर्जी है, ठीक फ्रीक्वेंसी है, अगर गलत है तो हमने फिर से चेंज करके, जब तक एटम रेजोनेट नहीं करता तब तक हम उसकी लाइट की फ्रीक्वेंसी चेंज करते रहते हैं। हाँ जी बताइए। बहुत अच्छा क्वेश्चन है आप, गुड, यू आर स्टूडेंट ऑफ फिजिक्स, आई एम वेरी हैप्पी। सो बेसिकली क्या है, एटम के अंदर बहुत सारे एनर्जी लेवल्स होते हैं, आपने बिल्कुल सही कहा। हम अभी लोएस्ट एनर्जी ट्रांजिशन की बात कर रहे हैं, जो सबसे कम वाला ट्रांजिशन है और जो बहुत कम एनर्जी को चाहिए होता है, जिसमें बहुत एनर्जी बहुत कम चाहिए, ना के बराबर चाहिए। तो ऐसा वाले ट्रांजिशन को हमने ढूंढा है, और ऐसा वाला ट्रांजिशन ये वाला ही ट्रांजिशन है जिसमें कि इलेक्ट्रॉन पैरेलल है और एंटी पैरेलल है। इसके बीच में जो एनर्जी ट्रांजिशन है, ये इसमें बहुत कम एनर्जी चाहिए होती है, और दैट इज व्हाई दिस एनर्जी इज वेरी वेरी स्मॉल, 9192631770 हर्ट्ज। अगर जो आप बात कर रहे हैं, अगर बहुत ज्यादा एनर्जी डाल देंगे तो फिर ऊपर वाले लेवल्स पे चला जाएगा एटम, और हमें उसके लिए भी एनर्जी को सिलेक्टिव डालना पड़ेगा। तब हो सकता है टेराहर्ट्ज डालेंगे हम, टेराहर्ट्ज मतलब बहुत हाई फ्रीक्वेंसी डालेंगे तो एनर्जी एक्साइटेड स्टेट में और ऊपर वाले में चला जाएगा। दैट इज ऑल्सो ए क्वांटम स्टेट। सो हियर हम जो बात कर रहे हैं वो लोएस्ट एनर्जी स्टेट की बात कर रहे हैं। जो लोएस्ट एनर्जी स्टेट्स हैं दोनों एटम्स के बीच में, एक्चुअली बोथ ऑफ देम आर ग्राउंड स्टेट्स, बिकॉज एटम ऐसे भी हो सकता है और एटम भी ऐसे भी हो सकता है। सो 50% एटम्स ऐसे होते हैं और 50% एटम्स ऐसे रहते हैं। सो वी आर टॉकिंग अबाउट दोज एनर्जी स्टेट्स, ओके। So consider that these are the two energy states. एक में it's like a magnet, the pointing up, north pole pointing up, here the south pole pointing up. So these are the two energy states. अगर हमें मैग्नेट को फ्लिप करना है तो हमें ये लाइट डालनी पड़ेगी। तो लाइट ये इसी फ्रीक्वेंसी की लाइट डालनी पड़ेगी। तो हम क्या करते हैं एटॉमिक क्लॉक में, अगर इतनी लाइट डालेंगे तो ये एटम फ्लिप होगा, एटम की एनर्जी स्टेट चेंज होगी, ठीक है। अब क्या करते हैं, हम इन वाले एटम्स को कलेक्ट कर लिया, इस वाले एटम्स को हमने एक ओवन में कलेक्ट कर दिया, क्योंकि अगर आपने स्कूल में कभी सोडियम को केरोसिन के अंदर डिप करके देखा होगा कि सोडियम हमेशा केरोसिन के अंदर डिप रहता है, क्योंकि अगर जैसे ही वो नहीं तो बर्न करने लगता है वो इट्स ए वोलेटाइल। व्हाई इट इज वोलेटाइल? बिकॉज इट इज ओनली हैविंग वन इलेक्ट्रॉन इन द आउटर मोस्ट ऑर्बिट। इट इज हैविंग इनफिनिटी टू एब्जॉर्ब वन फोटोन फ्रॉम ऑक्सीजन, वन इलेक्ट्रॉन फ्रॉम ऑक्सीजन। तो क्या होता है, जैसे ही वो एयर में लेके जाओगे तो वायलेंटली बर्न होता है, वो बर्न करने लगता है, जलने लगता है, क्योंकि वो ऑक्सीजन, एयर से ऑक्सीजन लेके सोडियम से सोडियम डाइऑक्साइड बन जाता है, पोटेशियम से पोटेशियम डाइऑक्साइड बन जाता है। सो इट स्टार्ट बर्निंग। सो सिमिलरली सीजियम ऑल्सो स्टार्ट्स बर्निंग व्हेन इट इज टेकन टू द एयर, सो इट इज ऑलवेज केप्ट अंडर वैक्यूम, and that is where these atoms are, these two energy states are, this one and this one. So now what happens that we select one of them, we throw one of the atoms out, जिसका साउथ पोल ऊपर है वो फेंक दिया हमने बाहर, सिर्फ नॉर्थ पोल जो ऊपर वाला एटम है उसको ले लिया, मतलब एक एनर्जी स्टेट को ले लिया हमने, और फिर उसके ऊपर लाइट डाली, 9192631770 हर्ट्ज की लाइट डाली, ये माइक्रोवेव से उसके ऊपर लाइट डाली। अगर लाइट ने उसकी एटम की स्टेट को चेंज नहीं करा तो क्या होगा, क्यों होगा ऐसा? मान लो मैंने लाइट डाली लेकिन एटम की स्टेट चेंज नहीं हुई, तो क्यों नहीं हुई? बिल्कुल करेक्ट, बिकॉज फ्रीक्वेंसी आप गलत दे रहे हो, उसके ऊपर जो फ्रीक्वेंसी लाइट डाल रहे हो गलत लाइट फ्रीक्वेंसी की लाइट डाल रहे हो। अगर करेक्ट फ्रीक्वेंसी की लाइट नहीं डाल रहे हो तो वो लाइट की एटम की स्टेट चेंज नहीं होगी। तो क्योंकि क्या हमने यहाँ पे जो लाइट डाली वो गलत फ्रीक्वेंसी करेक्ट नहीं थी, इनकरेक्ट थी, सो दैट इज व्हाई इट डिड नॉट चेंज द स्टेट। लेकिन जैसे ही मैंने लाइट की फ्रीक्वेंसी सही डाली, 9192631770 डाली, वैसे ही एटम की स्टेट चेंज हो गई। देखो यहाँ पे पहले रेड ऊपर थे, अब यहाँ पे ग्रीन ऊपर हो गए, तो एटम ने स्टेट चेंज कर ली अपनी, लाइट डालने से एटम ने स्टेट चेंज कर ली, और उसको डालते ही सब एटम्स यहाँ पे पहुंच गए। सो यू आर एबल टू डिटेक्ट द चेंज ऑफ द स्टेट। लाइट ने एटम की स्टेट चेंज करी, आपको पता चल गया कि एटम की फ्रीक्वेंसी करेक्ट है अब, सॉरी लाइट की फ्रीक्वेंसी करेक्ट है अभी, ठीक है। तो एटॉमिक क्लॉक के अंदर क्या होता है, एटॉमिक क्लॉक में जो है जो स्टेट्स होती हैं वो हम मेजर करते हैं। एटॉमिक क्लॉक में हम क्या करते हैं, एक एटम्स को लेते हैं, सीजियम एटम्स को लेते हैं, फिर उसकी एक स्टेट को लेके जाते हैं और माइक्रोवेव डालते हैं और दूसरी स्टेट से हम डिटेक्ट करते हैं। सो वी आर एबल टू क्रिएट दिस काइंड ऑफ ट्रांजिशन बिटवीन टू इलेक्ट्रॉनिक स्टेट्स। ओके, ब्रेक चाहिए आप लोगों को क्या? नहीं, इफ यू वांट ए ब्रेक यू कैन टेल मी, आई कैन ब्रेक। So I don't want you to leave in between, so that you continue with the flow of the class. Otherwise अगर आप बीच में ज्वाइन करेंगे तो हो सकता है कई सारी चीज़ें नहीं समझ में आए। So you let me know, madam, can you decide what time we should break and then maybe
Take 5 minutes break if everybody agrees.
और बाद में लेना है या अभी लेना है?
We will be having lunch break at 1 p.m.
उससे पहले किस समय ब्रेक लेना है?
Comfortable?
Because my class will continue to about 1 o'clock or so.
So we can take 5 minutes of break and we will join by 11:30.
Okay, because I have a long way to go.
Thank you.